Welcome and hello. This is a support video in HEC HMS. And in this video, I'm going to answer a following question that came in from a viewer about gridded spatial results. And the question is right here. Do I need to use a gridded precipitation method and provide a gridded precipitation dataset to view gridded spatial results of flow in HMS? I only have time series data from several gauges? And the short answer is no. You can definitely use different precipitation methods and still be able to see spatial results in your model. So what I'm going to do in this video is show you the results of this particular model, and then I'm going to show you some of the inputs that went into the model, and then we'll take a look at the results one more time. All right, so what I'm looking at here is actually a completed model run, simulation run 1. And up here in the spatial results toolbar, you can actually toggle on your spatial results toolbar by going on to the view menu, toolbars, spatial results. I already have it toggled on, but that's also how you toggle it off. Then you're going to select your variable, such as incremental precipitation. I only have 6 variables here because I have a very, very simple model for the purposes of making this video. And if I select on incremental precipitation, what you're seeing is the first hour of results. If I click the green play button, we see the results where we have precipitation happening over on the west side on day 1. On day 2, we're going to have precipitation occurring over here on the east side, the right side of the subbasin. And then on day 3 is going to be no precipitation. So as you notice, the play bar was scrolling across here, and now I'm going to click stop. All right, let's take a look at this model briefly. It is composed of a single subbasin with a sink at the end on this south end. This subbasin is geo-referenced. There are 4 different parameters or requirements for the spatial results to be active and available to you after running your model, and that is the first one. The basin model must be geo-referenced. So the basin model right here, it's called Basin 1. If I click on GIS, coordinate systems, I already went through the process when building this model of going through all the GIS steps to delineate the subbasin appropriately. You could very well have multiple subbasins. I'm just keeping it simple with one. Okay, the second requirement is that the subbasin discretization must be set to structured or unstructured. So go ahead and click on your subbasin or subbasins over here in the Watershed Explorer or in the main map. And then over here in the components editor, discretization method, I have set to structured, but you can also set it to unstructured. And then up in the discretization tab, I'm setting it to a cell size of 1000 meters. So if I wanted smaller cell size, I would change it to a smaller number, larger cell size to a larger number. And then after you do that, go ahead and click save. And then also what you want to do is click GIS, compute, and then grid cells. Now, I didn't make any changes, so it looks the same, but if I change the cell size, for instance, and then recompute it, it would look different. If you're still not seeing the actual grid across your subbasins, you're going to want to go up to View, Map Layers, and then toggle on this discretization layer checkbox. Okay, so that's number 2. Number 3 is that the subbasin transform method must use either Mod Clark or 2D diffusion wave. So again, click on your subbasin. The main subbasin tab right here has a transform method towards the bottom. Mod Clark is what I'm using, but there's also 2D diffusion wave. So if you're using Mod Clark, for instance, you do need to make sure to set the parameters here, which is time of concentration and storage coefficient. You do need to have positive numbers in these fields for the model to run. Okay, the fourth parameter here is to set the simulation's run spatial results to yes, and that needs to take place prior to running the model. So over here in the Watershed Explorer, click on the Compute tab, and then for the model, the simulation, which I'm calling Run 1, down here in the Components Editor, you want to make sure Spatial Results is set to yes, and Spatial Interval is also set, which I typically just set it to the smallest time interval, which is always the smallest time interval of the control specification, I believe. Yes, 1 hour, 1 hour. Now, if you're curious about the precipitation input, what I'm using is, for my meteorologic model, I'm using interpolated precipitation. So if I click on that interpolated precipitation icon, I have gauge D and gauge E. Gauge D is over here on the west side, and that's going to provide precipitation on day 1. Gauge E over here is on the east side. That's going to provide precipitation on day 2. and then day 3 has no precipitation. Over in DSS View, I have those two time series data sets right here, so I can bring them up. The royal blue is gauge D, which is on the west side of the subbasin. And then here in the lighter color blue, cyan, this is for gauge E. It's a little bit less precipitation, but I made it staggered so it's not at the same time, so we can actually see the variability in spatial results after running them on. Okay, so I'm going to go ahead and close that, minimize that, and just recognize that the interpolation method I'm using is inverse distance squared, but you can use a few other options as well. No radius of influence and no adjustment method, but those are also options. Okay, so let's go ahead and save and run one more time and then take a look at some different results. If I set the spatial results to none, I can just take a look at the overall runoff from the subbasin. The original question was about flow rate, but this is just going to be a single value at the sink. So I could click on the sink, view results, and then graph. This is the total runoff as a function of time for that 3-day simulation period. Of course, if you wanted more discretization, you could create smaller subbasins. But then for the incremental precipitation, I could run through the simulation once again, but what I want to do here is just right click and look at the spatial results at this particular location on the west side, which is going to have most of its precipitation on day 1 with a very little contribution of precipitation on day 2. However, on the east side, if I click on plot spatial results, I'm seeing a larger runoff, or sorry, more precipitation on day 2 and still a significant amount of precipitation on day 1 due to the distance of the two different gauges with respect to the subbasin. So I don't have them identified right now, but they're basically right here and right here on the west and east ends for gauges D and E respectively. Of course, there's other variables we could plot, such as the cumulative precipitation right here. Go plot spatial results. Now, in this situation, we have most of the precipitation occurring on the first day with a little bit on day 2. And then over here on the east side, we have a little bit on day 1, but most of it on day 2. All right, well, that's it for this support video. The quick answer was no, you do not need to have gridded precipitation data or use a gridded precipitation method to view spatial results on a grid within your subbasins.